Finally, one short note. If we were really interested in business cycle dynamics, the assumption that we've maintained so far, which is that agents don't care about leisure, is probably no longer reasonable. That means that we would want to change our preference structure so that it also includes leisure. Now, if we assume that the total amount of labor plus leisure that a particular person can use is limited, and let's assume that neither of these can be negative, then we can simplify matters and just say that then we can just replace this with 1 minus nt. What other changes would we need to make? Well, our production function would now need to include labor. So let's go with this as before. And nothing else needs to change. So now let's go with the recursive formulation, which is the same as before, but with a few changes. The most important is that now we must change the utility function. This is now 1 minus nt, the amount of labor supplied to production. The second is that we can replace consumption with this expression. Now, let's take the first order conditions. The first order condition of this thing with respect to capital in the future is going to be the same as before. This will become u prime times the derivative of this function with respect to its argument. One difference, of course, is that we need to be careful about which argument of this function the derivative is relevant for. In this case, it's the first one, which is consumption. Now let's go over here. It's the first argument, same discussion, and all of this, of course, has to be equal to 0. In this case, however, there is a second first order condition, which is with respect to n. And here we're going to have u prime again, except again we have to be careful about which argument we mean. This is u prime of 1, the first argument, times the derivative of the first argument with respect to labor. Labor doesn't show up here at all. So it does show up here, however. So we want this to the minus 1. Great. Next, we have to take the derivative of the utility function with respect to its second argument, because labor shows up there as well. Of course, that means we have the derivative of u with respect to its second argument here, times the derivative of what's in here with respect to n, which of course is -1. And finally, we need to take the derivative of this with respect to labor, and of course that's 0. And the whole expression must equal to 0. And note that this function gives us an implicit function n, which is determined by z, capital, and whatever ends up being the choice of capital tomorrow. So using this implicit function, we can actually eliminate n from our value function in principle and plug this in instead, leaving us once again with a value function that depends only on k and z, the state variables, where we're selecting k t plus 1, the state variable tomorrow. Z is selected by the transition function. And in that sense, having labor doesn't really change anything in our problem because its first order condition, which determines the optimal choice of labor given everything else, is not itself dynamic. There is no value function showing up in this first order condition.